Bismillahirrahmanirrahim. Today we are going to discuss the third lecture of chapter 15, and we know the chapter 15 is about the organic compounds. Dear students, when we are going to analyze any organic compound, there are two ways of analysis. First, we have to identify the elements present in the compound. So that kind of analysis in which we analyze or identify the elements present in the organic compound, that analysis is called as the qualitative analysis. And then after identifying the elements, we find the quantity, and that analysis is called as the quantitative analysis. So this lecture, that is about the qualitative analysis. Mean we have to identify the elements which are present in the organic compound. And this topic is related to our experimental work in the lab and some of the experiments you will perform in the laboratory during practicals. So this is the major topic about the identification of the elements in organic compound. So the content of the lecture, that is the detection of elements in the organic compound. And we know the organic compound, that is study of hydrocarbons, carbon and hydrogen. So today we will discuss different tests which we will perform in the lab to identify the elements. That is called a detection of elements. So first we will talk about the detection of carbon and hydrogens. Then detailed discussion about the detection of nitrogen, sulfur and halogens. And there might be one short question over there. And then detection of oxygen, phosphorus and how to detect the metals. Organic compounds, that is the study of hydrocarbons. So we know that the carbon is the essential constituent of all the organic compounds. And in addition to carbon, hydrogen is also present. But some of them may contain nitrogen, sulfur, halogens, oxygen, phosphorus and metals. So we have to perform the test to identify these elements. So first, the basic test to check the carbon and hydrogen in the organic compound. For that purpose, organic compound is heated with small amount of copper oxide in a glass test tube. So the carbon that will react with the copper oxide to make the carbon dioxide, and the hydrogen which is present in the organic compound, it will react with the copper oxide to make the water. So the presence of carbon dioxide is tested by passing through the lime water. So by the addition of lime water, and lime water formula is the calcium hydroxide, it will turn milky. So the formation of this milky lime water indicates the presence of carbon dioxide. And this carbon dioxide is formed due to carbon. It means the organic compounds contain the carbon. On the other hand, water, the presence of water is confirmed by adding anhydrous copper sulfate, and that anhydrous copper sulfate is white in color. So when there is a water, it will add with the copper sulfate and convert it to hydrous copper sulfate. Now its color is changed from white to blue. So the conversion of this white copper sulfate to blue copper sulfate shows that there is a formation of the water molecule. And the formation of water molecule is in turn from the hydrogen. So this is the confirmation, or this is the detection, that the organic compounds contain carbon and the hydrogen. Next, this is about the hydrocarbon, and we know that the other than carbon and hydrogen, some other elements may also present. For example, there may be some nitrogen, sulfur and halogens. So for the detection of nitrogen, sulfur and halogen, we perform a special test, and this test is given in your lab, in your experimental practical notebook for examination. So this test is special for the nitrogen, sulfur and halogens, and that test, that is called as the Lezine solution test, or you can make the extract that is called as the sodium extract. So we make a solution which is used for the detection of nitrogen, sulfur and halogens. So there is some procedure for the preparation of this Lezine solution. So in this case, we take some sodium metal we cut the sodium metal with a knife, and then we put this piece of sodium metal in a fusion tube. So we have a small tube, smaller, just like smaller, very smaller test tube, and then heat the fusion tube in a flame to melt sodium metal. So when sodium metal is melted, then add small amount of powdered organic compound into this fusion tube. Then heat the fusion tube again till its bottom become red hot. And when its bottom become red hot, then break this fusion tube in a china dish containing about 20 centimeter cube of water. We will boil, mix, and then filter the solution. Now this solution is going to filter, and the filtrate obtained, that is called as Lezine solution or sodium extract. So the question arises, why we make this sodium extract or the Lezine solution? We know the organic compounds, they have a covalent bond. So the formation of this Lezine solution means we are going to convert the covalent bonds into the ionic nature. So they will make the salt with the sodium. So when we make the sodium extract, we will divide this filtrate into 3 portions, and we will test separately for the nitrogen, sulfur and halogen. So these are the reaction which takes place when we heat the organic compound with the sodium. So for example, if the organic compound contains the sulfur, then sodium will react with the sulfur to make the sodium sulfide. If the organic compounds contain carbon, nitrogen and sulfur, so they will mix up and they will make sodium thiocyanate. And if there is only halogen, sodium will react with the halogen to make sodium halide. So these are the different compounds, these are different salts which are formed by heating with the sodium. So sodium with sulfur, sodium sulfide, sodium with nitrogen, carbon, sulfur, sodium thiocyanate, and with the halogen it make the sodium halide. So we perform the test for these 3 elements separately. So first we come to the nitrogen test. We take 1 part of the Lezine solution and we add a little bit of sodium hydroxide to make a little alkaline, mean basic. Then we add ferrous sulfate solution into it. And then this solution is boiled and few drop of FeCl3 and HCl are added. So look at the chemistry which is going in this reaction. So sodium, we know in the sodium extract, sodium react with carbon and nitrogen makes sodium cyanide. Then we are adding the ferrous sulfate. By the addition of this ferrous sulfate, this is converted into this complex. This is called sodium ferrocyanide. So this is about the complex chemistry and coordination compound, and we will discuss these kind of complexes in chapter 2 in detail in inorganic chemistry. And then we add ferric chloride, FeCl3. So what happened? This sodium is replaced with the iron. So this complex form a color, Prussian blue color, or the precipitate. So formation of this color or the precipitate indicates that organic compounds contain nitrogen. Sometimes there is a possibility that organic compound contain both nitrogen as well as the sulfur. So if nitrogen and sulfur both are present, then instead of Prussian blue color, we get a blood red precipitates. So it means the formation of this blood red precipitate shows that the organic compound contains both nitrogen as well as the sulfur. So if a blood red color is produced instead of Prussian blue color, then it proves that nitrogen and sulfur both are present in the organic. So the chemistry involved in this reaction, so the carbon is present, nitrogen and sulfur, they are combining to make NaSCN. And then the same reaction which is on the previous slide, the only difference is we have the sulfur over here. So now this was the sodium thiocyanate, we are adding the ferrous sulfate. This is ferrothiocyanate. Okay, so then this one again we at the end we added this ferric chloride, and this iron sodium is replaced with the iron. And now this is the formation of this blood red precipitate, indicates that organic compounds contain both nitrogen and the sulfur. Then if there is a compound which has no nitrogen, so we will test for the sulfur separately. So for the sulfur, we know that the sodium, if sulfur is present, it will react with the sulfur and it will make sodium sulfide. Now, what we will do, the second portion of the lysine filtrate is acidified with acetic acid and boiled to expel H2S. So by adding acetic acid into the sulfide, it will produce hydrogen sulfide gas. And then you add the lead acetate paper into that. So this lead acetate paper will react with H2S to make the lead sulfide black precipitates. So we can say that which turn lead acetate paper black, that indicates the presence of sulfur in the compound. So this is about the sulfur. So one part we started for the nitrogen, second part we took for the sulfur, and now the third part of this lysine solution we use for the halogen. So halogen may be chlorine, maybe bromine, maybe iodine. So in third portion of the lysine solution is boiled with the nitric acid to expel cyanide ions and sulfide ions. They might react with the silver nitrate. They might interfere. So we add silver nitrate solution. So these are the halide ions. We add the silver nitrates, means silver ion. It will react with this one, make silver halide. So the formation of precipitates show the presence of halogens. So from the precipitates, we can say that which halogen is present. So white, if there is a white precipitates, soluble in ammonium hydroxide shows the presence of chlorine. A pale yellow precipitates. So if the precipitates are light pale yellow, partially soluble in ammonium hydroxide shows the presence of bromine. And a deep yellow precipitates insoluble in ammonium hydroxide indicated the iodine. So this lysine solution test is also given in your practical notebooks, and you will perform these tests in the lab, and there is a chances of one short question from this lysine solution test. So first we have to say the procedure, and then tests for nitrogen, sulfur and halogen, and then their chemistry involved, so reaction. So we must know about the reactions of that. Then next, move toward the oxygen. So we know that organic compound may also contain the oxygen. So there are three different ways for the detection of the oxygen, but we have no direct method for the detection of oxygen, but some indirect method. For example, number one, if the substance is heated in a dry test tube, preferably in the atmosphere of nitrogen, inert environment, formation of droplets of water on the cooler part of the tube shows presence of oxygen. And if there is no formation of the droplets, it doesn't mean that organic compounds contain oxygen, in absence of oxygen. So the second method, that is, we perform the test of functional groups which have the oxygen. For example, alcohol, they have the oxygen. Aldehyde, they have the oxygen. Ketone, they has the oxygen. Nitro, they has the oxygen. Carboxylic acid, they has the oxygen. So we will perform the test of functional group. So the presence of that functional group indicates that oxygen is present. Now, the third method, which is the sure test of oxygen, that is on the determination of percentage of all other elements. So we find the percentage of all other elements, and we will get the percentage of oxygen. So we will minus the percentage of that one, and we will find the percentage of oxygen. So if the sum of these percentages fall short of 100, so for example, if there is a carbon, hydrogen, nitrogen, so their all percentages is going to become 90%. It means there is a 10% of oxygen. So we add the percentages of all the elements and we subtract from the 100. So that value shows the percentage of oxygen in the organic compound. Then come to the phosphorus. So for the phosphorus, solid substance is heated with oxidizing agents. You know the oxidizing agent which causes the oxidation. such as concentrated nitric acid, mixture of sodium carbonate and potassium nitrate. So the function of that is to convert, to oxidize this phosphorus to the phosphate. So phosphorus has oxidized to the phosphate, and then it is added with the water while with acid, and we add some hard solution of ammonium molybdate. We are going to get yellow coloration, and this yellow coloration precipitate shows the presence of phosphorus. Then the last, if there is some presence of some metals, for that purpose we heat that compound in crucible, just like a cup, just like china dish we know. So this is made up of platinum, and after the heating all the reaction stops, and then some residue is present, and this is which is going to burn. So that residue shows the presence of metal, and then this residue is extracted, meaning we add some acid and we add some water into that, and we perform the test of some metallic radicals by usual scheme which we use in the organic salts, for example sodium ion, potassium ion, like this one. So these are the tests for the identification of the element. So major, we have the reduction of carbon, hydrogen, and then most importantly the test for nitrogen, sulfur, and halogen. So we discuss detection of the elements, and from that our chapter is going to complete, and we will start the next chapter in the next lecture. So if you have any question, you can send me in the comment box. Thanks and best of luck.